Hi, this is Mrs. Nelson. We're going to be continuing our understanding of multiplying multi-digit numbers. Multi-digit again means multiple digits, so more than one digit, so two or more digits in each of the factors. The objective says I can represent multiplication of multi-digit numbers with an area model. So again, the area model is a stepping stone to getting us to the standard algorithm, but we want to see this because it helps us understand and grasp the concept of what it is that we're doing when we use the standard algorithm. So this problem says show 43 times 512 using an area model. So when I showed you an area model before, we broke each of the digits down into their place value. So I had a tens place and a ones place, a hundreds place, a tens place, and a ones place. But the cool thing with area models is you can build them how you want. You can start to get even more efficient with your area models if you consider the digits that you're working with. So I know how to multiply by 12. I know my 12 times table, so I'm actually not going to break that up into 1 10 and 2 ones. I'm going to keep that as 5 hundreds and 12. And so then I can still multiply by 12. I'm good at multiplying by 12. I don't need to break that down into something smaller. The other thing that's really cool about area models is that you can put the numbers wherever you want to, as long as you represent their place value. So instead of writing 40 and 3, I'm actually going to put 40 down here and 3 up here. It doesn't matter the order, as long as I represent 40, because this is 4 tens, instead of just writing a 4 and a 3. As long as I'm honoring the value of the digit based on its place value, then you can put it in whatever order you want. And so like I said, I'm going to break it down into 500 and 12 because I know my 12 times tables. So again, with the area model, this helps us think. We know the formula for finding the area of any rectangle is length times width. So I can use these two dimensions to help me consider how much the area would be of this. And what I'm going to ultimately do is find the area of all 4 of these rectangles, because that would represent the multiplication of 512 by 43. So in this box right here, I'm going to have 3 groups of 500. If it was 3 groups of 5, that would be 15, but it's not 5, it's 500. So it would be 3 groups of 500 would be 1500, or 1500. In this box, I'm going to do 40 groups of 500. If this was 4 groups of 500, that would be 500, 1000, 1500, 2000. That would be 2000 if it was just 4 groups of 500. But it's 40 groups of 500, so it's got to be 10 times bigger than 2000, so it's going to be 20,000. In this box, I need 3 groups of 12. This rectangle is 3 by 12, obviously not drawn to scale. So 3 groups of 12, I know that 3 times 12 is 36. And in this rectangle right here, it has dimensions of 12 and 40. So I need 40 groups of 12, or 40 times 12. So again, if this was 4 times 12, I know 4 times 12 is 48. So 40, being 10 times bigger than 4, would make my product 10 times bigger than 48, which is 480. So like I showed you in the last video, instead of having 4 add-ins, I want to combine some of the pieces that I can do mentally so that I can reduce the number of add-ins I have total. So I can easily add 1536 together and get 1536, and I can also easily add 20,000, and 480. So I can write that as 2 add-ins, 1536 plus 20,480, and that reduces my workload here of adding the individual pieces together. So when I add those, I have some regrouping that needs to be done, so I bundled up some numbers and carried them over to the next place value. But that gives me a total of 22,016. So that means 43 times 512 is 22,016. So these are big numbers. It seems intimidating, but when you use the area model, you break it down into chunks that are much easier for you to compute, and it helps you to represent the place values and not skip any steps. So I absolutely love the area model, and I support you using it anytime. And hopefully eventually you get to the point where you can do the standard algorithm and you don't miss any steps, and you get the same result in faster time because you don't have to build the area model. So we're always looking to efficiency, but we also need to understand the concept behind it. So I can represent multiplication of multi-digit numbers with an area model to help me understand the concept of multiplication. Thanks for watching.